What if the most powerful anti-aging treatments aren't found in a lab, but in your daily habits and you've been ignoring them your entire life? Prioritizing consistent, high-quality sleep is one of the most powerful, scientifically validated strategies for promoting cellular repair, metabolic balance, and overall longevity. Sleep is not simply a passive state of rest. It is an active biological process during which the brain and body undergo critical maintenance during deep, slow-wave sleep. The glymphatic system clears out accumulated metabolic waste products, including beta-amyloid and other neurotoxic proteins that, when left unremoved, contribute to cognitive decline and neurodegenerative diseases. This nightly cleansing process acts like a reset button, preserving brain function, memory formation, emotional stability, and neurological health over time. Sleep also plays a central role in hormonal regulation. When sleep is consistent and aligned with the body's natural circadian rhythm, hormones such as growth hormone, cortisol, melatonin, leptin, and ghrelin operate in balance. Growth hormone peaks at night to support tissue repair, muscle recovery, and metabolic function. Poor or irregular sleep disrupts this hormonal cycle, contributing to increased inflammation, accelerated aging of tissues, impaired immune function, an increased risk of chronic diseases such as diabetes, obesity, cardiovascular disease, and certain cancers. Even a single night of insufficient sleep can cause measurable declines in insulin sensitivity and elevate stress hormones. Making the body biologically older at the cellular level, circadian alignment is another essential aspect of healthy sleep. The timing of light exposure, meals, exercise, and screen use can shift or reinforce the body's internal clock. Exposure to morning sunlight helps synchronize circadian signals that regulate digestion, mood alertness, and nighttime melatonin production. In contrast, bright artificial light late at night, especially blue-enriched light from screens, suppresses melatonin, delays sleep onset, and reduces overall sleep quality. Over time, circadian disruption has been linked to increased inflammation, reduced metabolic efficiency, and shortened lifespan, making sleep timing just as important as sleep duration. Sleep quality is also deeply influenced by environmental and behavioral factors. A cool, dark, quiet room improves deep sleep by supporting thermoregulation and reducing microarousals that fragment sleep cycles. Caffeine, alcohol, and late-night eating can interfere with restorative sleep by disrupting autonomic nervous system balance and altering brain activity patterns associated with deep sleep and REM cycles, consistent sleep and wake times, even on weekends, help reinforce circadian stability and lead to more predictable hormonal and metabolic rhythms. On a cellular level, sleep promotes DNA repair and reduces oxidative stress, both of which directly influence aging. During sleep, the body activates pathways that repair damaged DNA strands, recycle cellular components through autophagy, and reduce inflammatory markers like cytokines and C-reactive protein. Without this nightly repair window, cells accumulate damage faster, leading to premature aging, decreased energy production, and diminished resilience to physical and mental stressors. Ultimately, prioritizing high-quality sleep is not a luxury, but a foundational biological necessity. Consistency in bedtime routines, alignment with natural light cycles, and optimization of the sleeping environment all contribute to healthier, longer-lasting cellular function, making sleep one of the most effective interventions for slowing the aging process. Combining strength training and cardiovascular exercise creates a synergistic foundation for maintaining muscle mass, metabolic efficiency, and heart health as we age. Strength training helps counteract sarcopenia, the natural decline in muscle tissue that accelerates with aging and leads to reduced mobility, lower metabolic rate, and increased risk of injury. Maintaining and building muscle improves insulin sensitivity, enhances balance and joint stability, and preserves bone density through mechanical load signaling. When muscles are consistently challenged through resistance exercises, they regenerate more efficiently, stimulate mitochondrial function, and produce myokines beneficial signaling molecules that reduce inflammation and support overall longevity. Without regular strength training, muscle fibers shrink, metabolic rate declines, and the body becomes more prone to fat accumulation and metabolic disorders. Cardiovascular exercise complements strength training by improving heart and lung capacity, increasing blood flow, and supporting vascular flexibility. Aerobic activity enhances the function of the endothelial lining of blood vessels, promoting better circulation and reducing arterial stiffness, which is a key predictor of cardiovascular disease and mortality. Activities such as running, cycling, swimming, or brisk walking strengthen the heart muscle, reduce resting heart rate, and improve oxygen utilization at the cellular level. These adaptations support mitochondrial efficiency, enabling cells to produce energy more effectively while producing fewer reactive oxygen species, which contribute to cellular aging when left unchecked. Consistent cardiovascular exercise is also strongly associated with lower rates of hypertension, stroke, and metabolic syndrome, making it an essential component of any longevity-focused regimen. The combination of both forms of exercise creates benefits that neither achieves alone. Strength training improves glucose uptake and stabilizes blood sugar, while aerobic exercise enhances fat oxidation and cardiovascular resilience. Together, they support metabolic flexibility, the body's ability to efficiently switch between burning carbohydrates, and fat switch declines with age and contributes to chronic inflammation and weight gain. Training both muscular and cardiovascular systems also supports balanced autonomic nervous system function, reducing sympathetic stress responses and enhancing parasympathetic recovery, which is crucial for hormonal stability and long-term cellular health. Exercise also directly influences brain aging. Physical activity increases blood flow to the brain, stimulates neurogenesis in the hippocampus, and elevates levels of brain-derived neurotrophic factor, a molecule essential for learning, memory, and cognitive resilience. Resistance training, in particular, has been shown to improve executive function and slow cognitive decline, while aerobic exercise enhances oxygen delivery and may protect against neurodegenerative diseases by reducing inflammatory markers and supporting vascular health in brain tissue. The combination of both modalities creates a robust environment for neurological longevity. Incorporating varied movement patterns further supports joint integrity, mobility, and functional independence. Compound lifts, interval training, and lump-packed endurance exercise provide diverse mechanical stimuli that challenge connective tissue and improve posture, coordination, and balance. As the body adapts, risk of falls, fractures, and mobility impairment decreases, allowing individuals to maintain strength and autonomy later in life. Regular training also enhances immune function, reduces chronic inflammation, and helps regulate hormones that influence appetite, mood, and sleep. Consuming a nutrient-dense whole food diet and incorporating time-restricted eating supports longevity by optimizing cellular function, reducing inflammation, and stabilizing metabolic pathways that typically deteriorate with age. Whole foods provide essential vitamins, minerals, fiber, antioxidants, and phytonutrients that processed foods lack, helping the body repair tissues, support immune function, and maintain a balanced microbiome. The gut microbiome plays a major role in regulating inflammation, hormone production, and immune responses, and its diversity tends to decline with age. Diets high in refined sugars, seed oils, and ultra-processed ingredients accelerate this decline, promoting chronic low-grade inflammation and metabolic dysfunction. In contrast, diets rich in vegetables, fruits, lean protein, legumes, nuts, and healthy fats supply the nutrients needed to maintain cellular integrity and metabolic stability. Protein intake becomes increasingly important with aging due to reduced anabolic sensitivity. Adequate protein distributed across meals supports muscle protein synthesis, preserves lean mass, and promotes recovery from physical stressors. Healthy fats from sources like fatty fish, olive oil, avocados, and seeds support brain health, regulate hormone production, and reduce inflammatory markers. Carbohydrates from whole food sources, such as whole grains, tubers, and fruits, provide sustained energy while supporting metabolic flexibility. When macronutrients are balanced with whole food sources, blood sugar remains more stable, reducing spikes in insulin that contribute to aging-related metabolic diseases. Antioxidant foods also play a critical role in slowing cellular aging by neutralizing free radicals and reducing oxidative stress. Compounds found in berries, leafy greens, cruciferous vegetables, turmeric, and green tea support pathways like NRF2 activation, which enhance the body's ability to detoxify and repair cellular damage. Polyphenols such as resveratrol, quercetin, and catechins have been studied for their influence on longevity genes and sirtuin pathways, which regulate cellular health and protect DNA from damage. These compounds work best when consumed through whole foods rather than supplements because they interact synergistically with fiber and other micronutrients. Time-restricted eating, a form of intermittent fasting, further supports metabolic health by giving the body extended periods without food, allowing insulin levels to decline and enabling stored fat to be used for energy. During fasting windows, cells activate autophagy, a process that removes damaged or dysfunctional components and recycles them into usable energy. This internal cleanup mechanism strengthens cellular resilience, improves mitochondrial function, and reduces inflammation. When eating windows are shortened to 8 to 10 hours, research shows improvements in insulin sensitivity, blood pressure, lipid profiles, and inflammatory markers. Aligning eating patterns with circadian rhythms enhances these benefits, as digestion and metabolism are more efficient during daylight hours than late at night. Reducing chronic nutrient overload is also essential. Constant snacking and high-calorie intake place persistent demand on metabolic pathways, leaving little opportunity for repair processes to activate. When the body cycles between fed and fasted states, it transitions more smoothly between anabolic and catabolic functions, supporting longevity at a cellular level. Additionally, avoiding late-night meals helps preserve sleep quality, hormonal regulation, and glucose control, preventing metabolic wear and tear. These combined dietary strategies support long-term vitality by optimizing cellular repair, reducing inflammation, enhancing metabolic flexibility, and aligning biological processes with natural rhythms, managing stress through mindfulness. Controlled breathing and restorative habits plays a critical role in slowing the biological aging process because chronic stress disrupts nearly every major system in the body. When stress becomes persistent, cortisol and adrenaline remain elevated, shifting the body into a constant fight-or-flight state that increases inflammation, weakens immune function, and accelerates cellular wear. Elevated cortisol also disrupts sleep cycles, impairs memory, increases abdominal fat storage, and interferes with metabolic processes such as glucose regulation. Over time, this hormonal imbalance contributes to cardiovascular strain, insulin resistance, mood disorders, and shortened telomere length, all of which correlate with faster aging. By reducing chronic stress and improving the body's ability to return to baseline after challenges. Restorative practices create a physiological environment more conducive to cellular repair and longevity. Mindfulness practices help regulate the nervous system by increasing activity in brain regions responsible for attention, emotional regulation, and executive function. Regular practice decreases activation of the amygdala, the brain's threat detection center, making stress responses less reactive and more controlled. Mindfulness-based interventions have been shown to reduce inflammatory biomarkers and improve immune resilience while supporting neurogenesis. In areas like the hippocampus, which is crucial for memory and cognitive aging. These practices also improve heart rate variability, a key indicator of autonomic balance and longevity. By strengthening the parasympathetic nervous system, instead of suppressing emotions, mindfulness allows individuals to process experiences with greater clarity, reducing psychological stress loads that would otherwise manifest physically. Controlled breathing techniques directly influence physiological stress responses by modulating the vagus nerve, which governs many processes related to relaxation, digestion, and cardiovascular stability. Slow, deliberate breathing reduces sympathetic arousal, lowers heart rate, and increases carbon dioxide tolerance, which improves oxygen delivery to tissues. Techniques such as cyclic sighing, box breathing, or diaphragmatic breathing shift the nervous system into a restorative parasympathetic state, promoting recovery and reducing inflammation. These methods can be practiced throughout the day and are especially effective before sleep, during high-pressure situations, or following strenuous physical or emotional exertion. Over time, regular breath work improves emotional resilience, decreases anxiety, and lowers physiological stress markers. In addition to internal practices, lifestyle habits that promote recovery also play a significant role in reducing stress-induced aging. Spending time in nature lowers cortisol, reduces blood pressure, and supports immune function through exposure to phytoncides and natural light. Regular physical activity acts as a natural stress regulator by releasing endorphins, improving mood, and clearing stress hormones from circulation, while also supporting sleep and metabolic balance. Social connection is another protective factor, as meaningful relationships buffer the effects of stress hormones and activate neural pathways associated with bonding and emotional safety. Isolation, by contrast, is associated with elevated inflammation, reduced cognitive function, and higher mortality risk. Restorative practices create space for the nervous system to reset rather than remain in a chronic activation loop. Activities such as journaling, creative hobbies, music, stretching, and mindful movement help release emotional tension stored in the body and allow mental processing that reduces accumulated stress load. When these habits are integrated consistently, the body becomes more adaptive, mounting appropriate responses to stressors while maintaining balance afterwards. Over time, this resilience supports healthier immune function, stable hormonal cycles, improved cognition, and reduced cellular aging by limiting exposure to damaging inflammatory and hormonal cascades. Getting daily natural light exposure supports circadian rhythm regulation, hormonal balance, and overall longevity because light is one of the most powerful environmental signals influencing biological timing. The body's internal clock operates on a roughly 24-hour cycle, regulating sleep, metabolism, cognitive performance, immune function, and hormone release. When light exposure is aligned with natural day-night patterns, this internal rhythm remains stable and efficient. Morning sunlight is particularly important because wavelengths contained in early daylight help signal the brain to suppress melatonin production and increase cortisol in a healthy, natural rise that supports alertness, focus, and metabolic activation for the day. This natural cortisol pulse differs significantly from stress-induced spikes because it aligns with circadian needs rather than fighting them. Without morning light, circadian rhythms drift, leading to grogginess, insomnia, and disrupted hormonal cycles that compound over time. Light exposure also influences neurotransmitter production. Sunlight stimulates retinal pathways that increase serotonin, which boosts mood, motivation, and mental clarity. Higher serotonin levels during the day support better melatonin synthesis at night, improving sleep onset and quality. Poor light exposure, especially during winter or in indoor environments, reduces serotonin availability and has been linked to mood disorders, decreased cognitive performance, and diminished energy regulation. Spending time outdoors during daylight hours helps stabilize these neurological pathways, supporting emotional resilience and preventing seasonal patterns of fatigue or depression. Even short, frequent exposures to natural light throughout the day provide metabolic benefits. Environmental light affects glucose regulation, appetite signals, and body temperature rhythms, all of which influence metabolic health. Exposure to midday light helps reinforce wakefulness and enhances vitamin D synthesis when ultraviolet radiation is sufficient. Vitamin D plays a crucial role in immune function, bone health, hormone regulation, and inflammation modulation. Deficiency is common in people who spend most of their time indoors and is associated with accelerated aging markers, reduced immunity, and increased risk of chronic disease. While supplementation may be helpful when sunlight is limited, natural synthesis offers additional physiological benefits that supplements alone do not fully replicate. Equally important is reducing exposure to artificial light at night, especially blue-enriched light from screens and overhead LEDs. Evening light suppresses melatonin production and delays internal clock signals that prepare the body for rest. Chronic exposure to bright light after sunset disrupts sleep quality, increases nighttime cortisol, and interferes with metabolic repair processes that occur during deep sleep. Over time, this pattern contributes to weight gain, elevated blood sugar, impaired recovery, and increased inflammation. Dimming lights after sunset, using warmer light sources, and limiting screen time before bed help maintain natural melatonin cycles and reinforce the transition to nighttime restoration. Light timing also affects cellular pathways related to aging. Consistent alignment of circadian signals supports gene expression cycles, mitochondrial function, and DNA repair processes that occur predominantly during sleep. When circadian rhythms are disrupted, cells become less efficient at coordinating energy use, clearing waste, and regulating oxidative stress. Natural light exposure anchors the body's internal clocks, allowing organs and systems to operate in synchrony rather than in conflict. This coordination reduces biological strain and supports long-term health by keeping metabolic, hormonal, and neurological rhythms in balance. Staying mentally engaged and socially connected plays a fundamental role in protecting cognitive health and slowing age-related decline because the brain depends on stimulation, novelty, and meaningful interaction to maintain neuroplasticity. When mental activity is consistent, the brain forms new synaptic connections, strengthens existing pathways, and preserves gray matter volume in areas critical for memory, executive function, and emotional regulation. Cognitive decline accelerates when the brain is understimulated, as neural circuits weaken from lack of use. Activities that challenge cognitive processings, such as learning new skills, solving complex problems, reading, playing strategy-based games, or engaging in creative work activate multiple brain regions simultaneously and promote neurogenesis in the hippocampus, which is especially vulnerable to aging. This stimulation enhances working memory, improves processing speed, and increases resilience against neurodegenerative conditions by creating cognitive reserve. Novelty-based learning has a uniquely powerful effect on brain health. When individuals engage in new experiences rather than repeating familiar routines, the brain releases dopamine, a neurotransmitter associated with motivation, reward, and memory encoding. Dopamine signaling declines with age, contributing to reduced drive, slower cognition, and decreased neuroplasticity. Introducing new hobbies, languages, musical instruments, or intellectual pursuits helps preserve dopamine pathways and keeps the brain adaptable. Continuous learning supports not just knowledge acquisition, but biological processes that maintain brain vitality. The more varied and challenging the stimuli, the greater the protective effect. As the brain thrives when pushed beyond predictable patterns, social interaction provides a separate yet complementary form of cognitive protection. Humans are inherently social organisms, and the brain is wired to interpret, respond to, and anticipate social cues. Conversations, relationships, and emotional engagement activate language centers, memory recall, empathy networks, and decision-making circuits. These interactions are cognitively demanding in ways that passive activities are not, requiring rapid processing of emotional signals, contextual memory, and verbal expression. Social isolation, on the other hand, is strongly linked to cognitive decline, increased inflammation, depression, and higher mortality rates. Loneliness affects the brain biologically by raising stress hormones, reducing immune function, and altering neurotransmitter balance. Maintaining meaningful relationships buffers these effects by promoting emotional stability and reducing physiological stress loads. Community involvement further strengthens longevity by reinforcing a sense of purpose and identity. Purpose-driven engagement, whether through mentorship, volunteering, shared hobbies, or group activities, supports mental health and reduces the risk of cognitive impairment. Purpose is associated with reduced inflammation, healthier stress responses, and improved cardiovascular function, all of which influence brain aging. Individuals with strong social roles and frequent social engagement tend to maintain sharper cognitive function and exhibit lower rates of dementia because their brains remain in constant adaptive use. Emotional connection also plays a role in supporting brain chemistry. Positive social experiences stimulate oxytocin release, which reduces fear responses, lowers cortisol, and improves emotional resilience. Strong relationships foster a sense of safety, reducing chronic stress patterns that accelerate cellular aging. Oxytocin pathways support trust, bonding, and emotional regulation, helping maintain mental stability even in challenging life phases. This biochemical reinforcement strengthens both psychological and physical health by aligning stress responses with connection rather than isolation. A lifestyle that integrates intellectual challenge with social engagement creates a powerful cumulative effect that reinforces neurological health. When the brain is consistently stimulated through learning and supported by meaningful relationships, its ability to adapt, repair, and remain resilient improves, preserving cognitive function and vitality as we age.